Hello learners. It's great to see you again. In this video, we will learn how a first-class lever allows us to lift or move a load with less effort.
Let's find out.
For this experiment, you will need a wedge, a 30 centimeter ruler, a 20-gram mass, and two 10-gram mass. To set up, use the wedge as a pivot and place it under the 10 centimeter mark of the ruler. Then, place the 20-gram mass at the 0 centimeter mark. Take note that the mass on this side of the ruler is the load. On the other hand, the mass that we will be adding on this side of the ruler represents the effort required to lift the load. Our ruler is now a first-class lever. We will now add the two 10-gram mass at the 20 centimeter mark. Observe what happens. Pause and share what you observed.
The ruler is now balanced.
That's right. Does it take the same amount of mass to balance the ruler if we were to place some mass at the 30 centimeter mark? Let's see. Pause and share what you observed.
No. We now only need 10 grams of mass to balance the ruler.
Yes. At the 20 centimeter mark, we need 20 grams of mass to lift or balance the load on the ruler. Meanwhile, at the 30 centimeter mark, we only need 10 grams of mass to lift or balance the load on the ruler. The effort needed at the 30 centimeter mark is half the effort required at the 20 centimeter mark. In general, the results show us that when the distance between the effort and the pivot increases, we need less effort to lift the load. This is how a first-class lever helps us to do work. Great job on completing the video. I hope to see you soon.